All right, so chapter 2 is all about polynomials, and rational functions. Okay, so specifically, what we're going to talk about in this first section is what 2.1 is all about. So 2.1 is about a specific type of polynomial, and that is the quadratic. So we're going to talk about quadratic functions. So that's what this first section is all about. Okay. A polynomial, right? So if we kind of come back to a polynomial, polynomial means many terms. Okay. And so a definition of a polynomial function. So definition of a polynomial function is going to kind of look like this, right? So I'm going to write this long kind of equation out and show you kind of what this means. So f of x is equal to a of n, and then this will be x to the power of n plus, and then this will be a n minus 1, x to the power of n minus 1 plus, and then there's a lot of terms in between, and then this will be a of 1, and then x to the power of 1, and then plus a of 0. Okay, and so basically a polynomial is defined by the highest degree. Okay, so if we have, say we just have our constant term, so we have f of x is equal to just a sub 0, right? This is known as a constant, right? So examples of this would just be, f of x is equal to 3, f of x is equal to 5, okay? If we have something that looks like this, f of x is equal to a of 1x plus a of 0, this is mostly known as your mx plus b form, right? So f of x is equal to, and again, some examples would be, f of x is equal to 3x plus 1, and these are all your linear forms because the highest degree is a power of 1, okay? So what happens if our highest degree is a power of 2? Then we have our constant term. So this would be an example, f of x is equal to, and then our general form that we are used to seeing is something like this, right? ax squared plus bx plus c. This is known as your quadratic function. And again, the highest degree is a power of 2. Your a cannot equal 0, because if your a equals 0, then this means that that term would go away, and you'd just be left with bx plus c, which then would be a linear function. Okay, so this is your quadratic function. With our quadratic function, right, the shape is a parabola. So the shape is a parabola, right? So it's kind of that U shape, right? It's either opening upward or it's opening downward. And if it's opening upward, that usually means your A is going to be larger than 0. And if it's opening downward, that means our A is going to be less than our 0. Okay? If I was to graph this, again, just general equations, right? Parabola. Whoop. I can draw that a little bit better. Let's try this one more time. All right, let's actually cross and touch. There we go. And so this would be kind of an example of just the general form. We're not shifting left and right. We're not shifting up and down. Your domain on this would always be all real numbers, and your range would be 0 to infinity, because it looks like it's crossing your 0. This would be an example of just f of x is equal to x squared. Okay. If I want to draw the other one, right, if I want to put a negative in front of it, right, our parabola would be opening downward, and it would look something like this. So our domain, again, would be all real numbers, or negative infinity to positive infinity. And this time your range would start at negative infinity and go to 0 with a bracket around it. So again, this would be our example of negative x. If we want to see this on graphs, so let's just actually see this. So x squared. So things I want to point out. Notice that this is your vertex, right? So it's the lowest point, or it could be the highest point. So right now this is our lowest point. And notice that the y-axis seems to be kind of, there seems to be symmetry along here. So notice that, you know, -2, 4, and 2, 4, they're the same distance from your y-axis. So there's symmetry. So this would be known as the axis of symmetry. If I want to put a negative, oops, sorry, I don't know where that went. If I want to put a negative in front, so let's put a negative in front of this. Now notice again, it's opening downward. So again, negative in front of our graph, so we can see the equation written right over there. So again, it opens downward, but still notice that 2 produces the -4, and -2 produces that -4. Again, these are two distances away from -4 or your y-axis. So there is there is some symmetry to our graphs. Right? So bring this back. So things to remember, right? So so we have a vertex. So our vertex is the highest or lowest point. If we think back to chapter 1, it is the max or the min point on our graph. Okay, we are going to have a formula in order to memorize it and create it. So our formula is x is equal to -b over 2a, right? This will find our x coordinate. So to find x coordinate, and then if I want to find the y coordinate, what I'm going to do is plug this into my equation, and so my vertex will be -b over 2a, because that would be your x, and then this would be f of -b over 2a. Right? So again, our vertex is the highest or lowest point on our parabola. So again, this point right here would be your vertex. And again, this point right here would be your vertex. Okay? Your vertex, again, is an equation right here. X is equal to. It's also part of your axis of symmetry, right? So again, your graph that cuts your equation or your graph into two equal and symmetric points, again, cuts through your vertex. So axis of symmetry is going to intersect with the vertex. Okay, and again, how do we find the axis of symmetry? It is x is equal to -b over 2a. The b and the a do again come from our equation, a and bx right there. Okay, what else can we find on here? We are going to have x-intercepts. So x-intercepts is where it crosses, just in case we forget, crossed the x-axis. And how we are going to find that is by factoring. So we can factor to find our x-intercept. So again, it'll be some number, comma, 0, right? Or we can use the quadratic formula. So quadratic formula. So x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. So again, factoring is going to be a little bit easier. Quadratic formula will help us find it all easily. So again, it's our x-intercepts where it crosses your x-axis. You may or may not have x-intercepts. So you may or may not have x-intercepts. Right? Because what happens if your parabola looks something like this? Right? It looks like it's floating. It's never crossing your x-axis down here, so I mean I wouldn't have any. And again, it wouldn't be factorable, and the quadratic formula would not produce a valid answer. Okay? Not only do I have x-intercepts, but I will always have a y-intercept. So again, a y-intercept, if we forget, it crossed that y-axis, you will always have a y-intercept. Yay! So your y-intercept is always going to be 0, comma, some number. And if we remember our general formula, ax squared plus bx plus c, again, equal to f of x, that means I plug a 0 in, this will go away, this will go away. So technically, this is always your c, right? So whatever value is your constant will also be your y-intercept. Okay? Then we have another form. So again, here's our general, this is our general form. So ax squared plus bx plus c, so general form. And we also have what's known as the standard form. So x minus h squared plus k. So this is known as the standard form. You might have remembered this as your vertex form because your vertex is your h and your k. Okay, again, your a value and this a value are going to be back and forth. They're going to be the same value. So again, we're going to do some practice problems to getting from one way to the other. What we can do is we can complete the square in order to go from general form to standard form. So there's a lot of different things that we can do. So in our next video, we are going to be looking at how we can find how we can go from the general form to the standard form, how we can find our vertex. So we're going to have practice using this equation. How do we find our x-intercept? So we'll factor, we'll do a quadratic formula or two, and that's what's going to be in the next video.